So let us start with the explicit Eulerian time forwards. What you did is you used the original equation that governs the decay problem and formulate the left-hand side in terms of a difference, a forward difference we call it, divided by a time step. And on the right-hand side you use concentration at the current time level. Alrighty, so now how it works in terms of a computer code is you always have everything that you know on the right-hand side of the equation, and on the left-hand side of the equation there is the unknown. Okay, we also call it the predictor or the prediction. Okay, so you start with this equation here at the top, and then you use basic mathematics to sort this equation. Okay, so what the unknown is Cn plus 1. Okay, that's on the left-hand side. And then you rewrite everything, and I'll just move away a little bit here, and you can see this is everything is unknown. It's concentration at the current time level. Sorry, this is all known, all right? Here on the right-hand side, this is just 1 minus delta T times kappa. And there's a different types of constants that you have. Delta T is a model constant. This is the time step. This is the time step, and this kappa is a physical parameter that you also prescribe. Everything here is known, and from one day now, if you think about the wine thief example, you can go from one day and do a prediction for what is the concentration in the next day, Cn plus. Okay, but then you can repeat it. You step forward in time. You step forward one day, and then you can do the same thing. What is it another day ahead? You plug it in, the value, and again get a prediction. And this is what we call an iteration. So you start at with some initial value. It's also called an initial value problem. You can only do it if you know what the initial concentration is, right? And then you can repeat and repeat and repeat and repeat. This is an iteration. And this is one way to solve it. However, there's one problem, and you might spot the problem. There's one problem. There's this bracket term here, and you have to make sure that this term is positive and that it has a value below 1, because otherwise you run into problems. This is what we call a stability condition. When we talk about that, we shall do that on the next